For more than 160 million years, dinosaurs dominated the land, not as legends, not as movie monsters, but as real animals, living in real ecosystems, facing real biological limits. They were born, they grew, they were injured, they became sick, they starved, they protected their young, and eventually, every single one of them died. When people imagine dinosaur extinction, they picture a single instant, a fireball in the sky, a shockwave, and a world that ends overnight. But that image is incomplete. Because extinction was not one moment, it was millions of individual deaths unfolding over time, long before the final catastrophe ever arrived. The fossil record does not show dinosaurs simply disappearing. It shows struggle. It shows predators that never finished a hunt, parents that never left their nests, animals trapped where they stood, unable to escape, bones marked by infection, disease, and trauma that lasted weeks, months, sometimes years. And in extremely rare cases, geology did something extraordinary. It stopped time. It preserved final moments so precisely that we can still see how these animals died. Which bones broke first? Which teeth were embedded? Which wounds became infected? Which bodies never even had time to fall? These fossils are not stories. They are not guesses. They are physical records, locked into stone by sediment, ash, and catastrophe. Today, we are examining the 10 most tragic dinosaur deaths ever scientifically recorded, based entirely on fossil evidence, stratigraphy, bone pathology, and sedimentology. Every case comes from peer-reviewed discoveries. Every location is dated. Every conclusion is grounded in anatomy and geology. This is not speculation. This is not imagination. This is what the rocks actually remember. 75 million years ago, during the late Cretaceous, the region that is now southern Mongolia lay near the northern edge of the Asian continent. This landscape was not lush or tropical. It was a harsh, semi-arid desert environment, known today as the Jiadokta Formation. The terrain was dominated by towering sand dunes, sparse vegetation, and frequent violent sandstorms, capable of burying entire animals within minutes. It is within this environment that one of the most famous fossils in paleontology was created, a fully articulated Velociraptor mongoliensis and a Protoceratops andrewsi, preserved together in direct physical combat. The Velociraptor was a small but highly specialized predator, weighing roughly 15 kilograms, equipped with a stiffened tail for balance, grasping forelimbs, and an enlarged sickle-shaped claw on the second toe of each foot. That claw was not used for slashing. Biomechanical studies indicate it functioned as a piercing and gripping weapon, designed to latch onto prey and hold it in place. The Protoceratops, in contrast, was a stocky, quadrupedal herbivore weighing over 100 kilograms. It possessed a powerful parrot-like beak, a thick skull, and a solid frill that anchored strong neck muscles. While not fast, it was far from defenseless. The fossil shows the Velociraptor's left sickle claw embedded deep into the Protoceratops' neck region, near the cervical vertebrae. This placement suggests the predator was attempting to deliver a disabling wound, possibly targeting blood vessels or the spinal cord. At the same time, the Protoceratops' beak is clamped tightly around the Velociraptor's right forearm. The grip is so firm that the Velociraptor's arm bones are fractured, indicating intense bite force applied before death. Neither skeleton shows evidence of healing. This was not an old injury. This was a moment frozen in progress. Both animals are fully articulated, meaning their bones remained connected exactly as they were in life. There are no tooth marks from scavengers, no dismemberment, no scattering. This tells us something critical. Whatever killed them happened fast. Sediment analysis of the surrounding rock shows fine, wind-blown sand consistent with rapid burial. The most likely cause was a sudden dune collapse or a powerful sandstorm, both common in the Jiadokta Formation. Such events could bury animals alive in seconds. Neither dinosaur was able to disengage, neither escaped. Both likely suffocated as sand filled their lungs while they were still locked together. The Velociraptor never withdrew its claw. The Protoceratops never released its bite. Discovered in 1971 by a Polish-Mongolian expedition, this fossil remains the only known example of a dinosaur predator and prey preserved dying together in combat. Not inferred, not reconstructed, directly recorded, it is one of the clearest demonstrations that dinosaur predation was violent, close quarters, and often fatal for both participants. This was not a clean hunt. It was mutual destruction, captured at the exact moment nature intervened. Approximately 70 million years ago, during the late Cretaceous, the Nemegt Basin of what is now southern Mongolia was a broad floodplain interrupted by dune fields and seasonal deserts. This region experienced long, dry periods punctuated by sudden, violent sandstorms, driven by shifting wind systems. Within this environment, an adult oviraptorid dinosaur had constructed a nest directly on the ground and was actively brooding a clutch of eggs. The fossil specimen was discovered preserved in situ, positioned directly atop the egg ring, with no displacement of bones and no disturbance to the nest structure. The forelimbs are spread symmetrically over the eggs, forming a protective arc. The hind limbs are folded tightly beneath the body, supporting its weight in a crouched posture. The tail curves around the nest perimeter, This posture is not random. It is biomechanically identical to the brooding posture used by modern birds, where body heat is transferred directly to developing embryos. Detailed analysis of the eggs shows they were arranged in a circular pattern, with their pointed ends angled inward. This arrangement allowed the adult's body to cover the entire clutch efficiently, while leaving space for airflow and temperature regulation. Prior to this discovery, oviraptorids were widely interpreted as egg thieves. Early fossils were found near nests, and without context, paleontologists assumed these animals were stealing eggs from other dinosaurs. This specimen permanently disproved that idea. The adult was not raiding the nest, it was incubating it. Grain size analysis of the surrounding sediment reveals fine, windblown sand with no evidence of water transport. This indicates rapid aeolian deposition, consistent with a sudden sandstorm rather than flooding. There are no signs of trampling, struggling, or repositioning of the skeleton. The animal did not attempt to flee. There is no defensive posture, no change in orientation, no evidence that the adult abandoned the nest. The conclusion is unavoidable. The oviraptorid remained on the eggs as the storm struck and was buried alive. Death likely occurred by suffocation, as sand filled the respiratory passages, a process that would have taken minutes, not hours. The eggs themselves are intact. There is no evidence of hatching. The parent died before the clutch could develop further. This fossil represents the first direct skeletal evidence of parental care in non-avian dinosaurs. Not inferred from behavior, not guessed from anatomy, physically preserved at the moment of death, it also demonstrates that dinosaurs prioritized reproduction in ways strikingly similar to modern birds, even at the cost of their own survival. This was not an accident of position. This was a conscious biological decision recorded permanently in stone. 125 million years ago, during the early Cretaceous, the region that is now Liaoning Province in northeastern China was a volcanically active landscape. This area, known today as the Yixian Formation, consisted of forested floodplains, shallow lakes, and frequent volcanic eruptions that periodically blanketed the region in ash. These eruptions are the reason Liaoning preserves some of the most detailed dinosaur fossils ever discovered. Within this environment, a small troodontid dinosaur known as Meilong settled down to rest. Meilong, meaning sleeping dragon, was a lightly built, feathered theropod measuring less than 1 meter in length. It possessed long hind limbs, grasping forelimbs, and a relatively large brain compared to body size, consistent with other troodontids. The fossilized skeleton is preserved in a tightly curled posture. The head is tucked beneath the forelimb. The neck is flexed inward. The tail is wrapped around the body. This configuration is not accidental. Biomechanical and comparative anatomical studies show that this posture closely matches thermoregulatory sleeping positions used by modern birds. By tucking the head and reducing exposed surface area, the animal conserved body heat and protected vulnerable regions during rest. The articulation of the skeleton is complete. All bones remain connected. There is no evidence of limb extension, thrashing, or defensive movement. This indicates the animal was not awake during burial. Stratigraphic analysis places the fossil directly beneath a fine-grained volcanic ash layer. The ash shows characteristics of rapid deposition, not slow accumulation. Geochemical analysis of similar layers in the Yixian Formation indicates the presence of volcanic gases capable of displacing oxygen, including carbon dioxide and sulfur dioxide. Such gases are heavier than air and can flow rapidly along the ground, filling low-lying areas. If released suddenly, they can cause loss of consciousness within seconds. The dinosaur did not change position. There are no fractures associated with impact, no evidence of escape behavior, no signs of muscle contraction at death. This strongly suggests death occurred rapidly, either through suffocation caused by oxygen displacement or near-instant burial under ash before the animal could wake. The preservation of the sleeping posture indicates the nervous system never triggered a flight response. Death was effectively immediate. This fossil represents the clearest known evidence of a non-avian dinosaur dying while asleep, not inferred from bone position, not reconstructed, directly preserved in a natural resting pose. It also provides compelling evidence that complex sleep behaviors seen in modern birds were already present in small theropod dinosaurs over 100 million years ago. In this case, volcanism did not just preserve anatomy, it captured behavior. A moment of rest abruptly ended, locked permanently into stone. The Yixian Formation did not preserve isolated tragedies. It recorded entire ecosystems caught mid-collapse. In the same volcanic landscape that sealed Meilong in its sleeping posture, another fossil captured a far more violent moment. This time, the victim was not asleep. It was fighting for its life. The specimen comes from the same early Cretaceous deposits of Liaoning and dates to approximately 125 million years ago. It preserves a juvenile Psittacosaurus locked in direct physical combat with Repenomamus robustus, one of the largest mammals known from the Mesozoic. The Psittacosaurus was young. Its skeletal proportions indicate it had not yet reached sexual maturity. At this stage of development, it lacked the robust musculature and mass that adult individuals used for speed and endurance. Its primary defense would have been rapid movement and evasive behavior. Repenomamus robustus was not a passive animal. At over 1 meter in length and weighing up to 14 kilograms, it was built for active predation. Its jaws were deep and reinforced. Its teeth were thick and conical, capable of penetrating bone. This mammal was anatomically equipped to attack vertebrate prey. The fossil preserves the mammal's jaws, locked onto the dinosaur's lower jaw and hind limb. The bite placement is critical. Targeting the jaw limits defensive biting. Gripping the hind limb restricts escape. This is a controlled attack sequence, not random contact. The dinosaur's body position indicates active resistance. Limbs are flexed. The tail is not relaxed. There is no evidence of collapse prior to burial. Microscopic examination of the bones shows no weathering, no scavenger damage, and no post-mortem disarticulation. Both animals were alive at the moment burial began. The surrounding sediment is composed of fine volcanic mudflow material. These deposits are consistent with lahars, which form when ash mixes with water and surges downslope at high velocity. Lahars do not allow escape. They engulf organisms rapidly and solidify in place. Stratigraphic analysis confirms both skeletons were entombed simultaneously. There is no evidence one survived longer than the other. Neither animal escaped the encounter. The predator did not finish the kill. The prey did not break free. Both died because the environment failed catastrophically around them. This fossil forced paleontologists to revise long-standing assumptions about mammalian behavior during the Mesozoic. Early mammals were not universally small, passive, or strictly insectivorous. Some were capable of attacking dinosaurs directly. This specimen provides direct skeletal proof that mammals occasionally occupied higher trophic roles than previously recognized. However, the fossil also shows the limits of biological dominance. Despite anatomical advantages, Repenomamus was still vulnerable to sudden geological events. In this ecosystem, survival was not determined solely by size, strength, or intelligence. It was dictated by the stability of the landscape itself. The Leoning deposits repeatedly demonstrate this pattern. Dinosaurs asleep, predators mid-attack. Entire communities halted without warning. Volcanism did not discriminate between hunter and hunted. It erased both equally. And this pattern becomes even more evident when individual deaths give way to something far larger: mass mortality. Entire groups eliminated not by predators, but by environmental traps that allowed no escape. Roughly 90 million years ago, during the late Cretaceous, a group of juvenile Ornithomimids dinosaurs congregated along the edge of a shrinking lake in what is now Inner Mongolia. The site is located within the Ulansuhai Formation, a sedimentary unit known for fluctuating environmental conditions driven by alternating wet floodplains and prolonged drought cycles. This was a highly unstable landscape. Water sources expanded seasonally and then receded, leaving behind deceptively soft sediment surfaces. The fossil assemblage recovered from this site is highly unusual. Every individual present is a juvenile. There are no adult skeletons. There are no hatchlings. Bone histology and growth ring analysis show that all individuals were adolescents, not fully grown, but well past early development. This indicates the group was age segregated. Paleontologists interpret this as a juvenile cohort, likely separated from adults during seasonal migration, nesting periods, or as part of a social structure where younger individuals formed independent groups. Such age-based grouping is seen in modern birds and some herd animals. As drought conditions intensified, surface water became scarce. The juveniles approached the margin of the lake to drink. What appeared to be solid ground was actually water-saturated sediment with low shear strength. As the dinosaurs stepped forward, their weight caused their feet to sink rapidly into the substrate. Once embedded, the mud behaved like a trap. Trackways preserved around the skeletons show deep, steeply angled plunge marks. These impressions slope backward, indicating the animals were pulling with force, attempting to free their legs. The deeper they struggled, the more the sediment liquefied beneath them. Several skeletons show abnormal limb orientations, consistent with collapse due to exhaustion. At least 2 individuals are preserved directly on top of one another. This stacking confirms that multiple dinosaurs became trapped simultaneously and died within the same time window. This was not a single accident. It was a cascading failure. As more animals entered the mud, the substrate destabilized further. The fossil assemblage shows missing pelvic elements in several individuals. Detailed examination revealed tooth marks consistent with carnivorous theropods. This indicates predators were drawn to the site while the juveniles were immobilized. Some dinosaurs were likely bitten and partially consumed while still alive, unable to escape. Others may have died first from dehydration, exhaustion, or suffocation as the mud restricted chest expansion. Importantly, there is no evidence of a sudden burial event. No volcanic ash layer, no flood deposit, no rapid sediment collapse. This site represents a prolonged mortality event. Death occurred over hours or days, not seconds. The dinosaurs did not drown. They were trapped. They weakened. They collapsed. They died where they stood. From a paleoecological perspective, this site provides rare insight into dinosaur social structure. Juvenile-only groupings suggest behavioral complexity. From a taphonomic perspective, it is one of the clearest examples of attritional death rather than catastrophic burial, and from a biological standpoint, it documents one of the most vulnerable moments in a dinosaur's life stage. Not hunted, not ambushed, not struck down by disaster, but undone by environmental instability and inexperience. The Allosaurus Ornithomimids site is considered one of the most emotionally striking mass mortality assemblages ever excavated, not because of violence, but because it records prolonged suffering, helplessness, and loss within a single age group. And this was not an isolated phenomenon. Across the fossil record, entire herds met similar ends. Sometimes the trap was mud, sometimes it was water, sometimes it was the ground itself collapsing beneath their feet. And one of the largest such tragedies occurred not in Asia, but beneath the forests of ancient Europe. 125 million years ago, during the early Cretaceous, a herd of Iguanodon bernissartensis moved through a swamp-dominated lowland forest in what is now southern Belgium. At the time, this region was a warm, humid landscape dominated by wetlands, slow-moving rivers, and dense vegetation. The site would later be discovered deep underground in the Bernissart coal mines and would become one of the most important dinosaur fossil localities ever excavated. Within this single site, paleontologists recovered more than 30 articulated Iguanodon skeletons, many of them nearly complete. The preservation is extraordinary. The skeletons are stacked vertically and diagonally, overlapping one another in confined space. This arrangement immediately ruled out surface burial by flooding or volcanic ash. Stratigraphic and sedimentological analysis instead points to a doline collapse. A doline is a sinkhole formed when groundwater slowly dissolves soluble rock, such as limestone, beneath the surface, creating a hidden cavity. For long periods, the ground above appears stable, but when weight exceeds structural tolerance, collapse is sudden and catastrophic. Geological evidence indicates that this cavity filled with water and fine sediment, creating a deep, steep-sided pit. As the Iguanodon herd gathered near the water source, the roof of the cavity failed. Multiple individuals slid into the sinkhole almost simultaneously. The angles of limb articulation and spinal orientation show uncontrolled descent rather than deliberate movement. Once inside, escape was effectively impossible. Adult Iguanodon weighed up to 4 tons. Their hind limbs were powerful, but poorly suited for climbing steep, collapsing slopes. The pit walls were unstable, slick with mud, and continuously slumping. Some individuals likely drowned. Others may have suffocated, as their chests were compressed under sediment and other bodies. Geochemical analysis of the surrounding sediments suggests another lethal factor. Disturbance of anoxic swamp layers may have released hydrogen sulfide gas. Hydrogen sulfide is heavier than air and accumulates in low areas. At high concentrations, it causes rapid respiratory failure. This could explain why some individuals appear to have died quickly without extensive struggle marks. Importantly, there is no evidence of predation, no tooth marks, no dismemberment, no scavenger damage. This was not a selective kill. It was an environmental trap. The skeletons are preserved in collapse-consistent orientations, with heads angled upward and limbs splayed, matching modern sinkhole mortality patterns seen in large mammals. The Bernissart assemblage represents a single catastrophic event, not repeated deaths over time. It demonstrates how herd behavior, body mass, and geology combine to create a lethal scenario. These animals were not weak, they were not sick, they were not starving, they were simply in the wrong place at the wrong moment. The Bernissart Iguanodon site remains one of the clearest examples of non-predatory mass dinosaur mortality ever documented. It shows that during the age of dinosaurs, death did not always come from teeth or claws. Sometimes it came from the landscape itself, and even the largest, most successful herbivores were powerless when the ground beneath them failed. 147 million years ago, during the late Jurassic, the floodplains of what is now Wyoming were home to some of the most iconic dinosaurs ever discovered. Among them was Stegosaurus armatus, a heavily built herbivore protected by dermal plates and armed with a tail ending in 4 long spikes. Sharing this environment was Allosaurus fragilis, the dominant large theropod predator of the Morrison Formation. Direct fossil evidence shows that at least one encounter between these two species ended disastrously for the predator. The specimen in question is an Allosaurus pelvis bearing a single circular puncture wound. The dimensions of the wound match precisely the cross-section of a Stegosaurus tail spike. No other dinosaur weapon in the Morrison Formation produces injuries of this size, shape, or orientation. The spike penetrated the pelvic region, striking bone rather than soft tissue. Crucially, the margins of the wound show clear reactive bone growth. This indicates the Allosaurus survived the initial trauma. The bone attempted to heal. However, healing did not mean recovery. Surrounding the puncture site is extensive pathological remodeling. The bone surface is irregular and porous, consistent with a severe infection. Paleopathological analysis identifies this as a large abscess, likely caused by bacteria introduced deep into the bone at the moment of impact. Such infections are common in modern animals, following penetrating injuries, especially when debris or organic material is driven into tissue. The pelvis plays a critical role in locomotion. It anchors major hind limb muscles responsible for walking, running, and supporting body weight. Damage in this area would have caused extreme pain and severely restricted movement. For a large theropod that relied on active pursuit and ambush hunting, this injury would have been catastrophic. As the infection spread, the Allosaurus would have become increasingly immobile. Hunting would have been difficult or impossible. The animal likely lost the ability to chase prey or compete with other predators. Without regular access to food, starvation would have followed. Alternatively, the infection itself may have progressed into systemic sepsis, leading to organ failure. Either outcome points to a prolonged and debilitating death rather than a sudden one. This fossil is critically important because it demonstrates a reality often overlooked. A predator does not need to be killed outright to be doomed. Injury alone can be fatal. The Stegosaurus did not need to overpower its attacker. A single defensive strike was enough to seal the predator's fate. This specimen provides rare, direct evidence that prey animals were capable of inflicting lethal injuries on apex predators. It also highlights the hidden cost of survival in prehistoric ecosystems. Escaping an encounter alive did not guarantee recovery. For large theropods, even a single successful hunt gone wrong could result in weeks of suffering followed by death. This was not a victory, it was a delayed fatal outcome, and the fossil record preserves it with clinical clarity. 50 million years earlier, during the late Jurassic, another Allosaurus fragilis lived a far harsher and more prolonged struggle for survival. The specimen now known as Big Al was discovered in the Morrison Formation of Wyoming and represents one of the most intensively studied dinosaur skeletons ever recovered. Unlike many fossils that record a single traumatic event, Big Al's bones preserve a lifetime of injury and disease. Detailed examination identified more than 19 separate pathological conditions. These include fractured ribs that healed unevenly, broken toes, abnormal joint surfaces consistent with degenerative arthritis, and extensive skeletal infection. The most severe pathology is located in the right foot. The third toe shows clear evidence of osteomyelitis, a deep bacterial bone infection. The bone is massively swollen and deformed, with irregular porous growth replacing normal structure. This type of pathological remodeling only occurs when infection persists over an extended period. It was not a sudden injury, it was chronic. Biomechanically, the middle toe is essential for weight distribution and propulsion in large theropods. Damage at this location would have altered Big Al's gait, reducing speed, balance, and endurance. For an animal that relied on pursuit, ambush, and physical dominance to obtain food, this impairment would have been devastating. Every step would have placed stress on infected tissue. Every movement would have intensified inflammation. The infection likely spread intermittently, causing episodes of fever and systemic weakness. Importantly, Big Al was not an old individual. Histological analysis of the bones shows incomplete growth. The animal died before reaching full adult size. This was not natural senescence. This was early mortality caused by cumulative trauma and disease. As injuries accumulated, Big Al's ability to hunt would have declined. Missed kills, reduced speed, increased vulnerability to competition from other predators. Scavenging may have supplemented its diet, but scavenging alone would not sustain a large theropod indefinitely. Eventually, starvation becomes unavoidable. The most likely cause of death was a combination of malnutrition, systemic infection, and physical exhaustion. There is no evidence of a final violent encounter, no catastrophic trauma, no predator marks. Big Al simply deteriorated. This fossil is crucial because it reveals a side of dinosaur life rarely shown. Not dominance, not spectacle, but endurance under constant physical stress. It demonstrates that dinosaur ecosystems were unforgiving. Around 67 million years ago, during the final million years of the late Cretaceous, a Tyrannosaurus rex, now known as Sioux, dominated the wetlands and river systems of what is now North America. Sioux's skeleton is among the most complete T-Rex specimens ever recovered, allowing paleontologists to study not just anatomy, but health, injury, and disease in unprecedented detail. While examining the skull, researchers identified a series of smooth-edge perforations in the lower jaw. These lesions were immediately notable. They do not match the jagged, fractured margins expected from bite wounds. They show no signs of impact trauma. Instead, the holes are rounded, evenly bordered, and internally eroded. Initial hypotheses proposed intraspecific combat, bites from another T-Rex, but further microscopic and comparative analysis ruled this out. The morphology of the lesions closely matches trichomoniasis, a parasitic infection caused by Trichomonas protozoans. This disease is well documented in modern birds, particularly raptors and pigeons. In living animals, trichomoniasis causes necrotic tissue growth in the mouth, throat, and upper digestive tract. As the infection progresses, lesions enlarge and merge, forming obstructive masses that interfere with swallowing and breathing. Victims often die not from the infection itself, but from starvation or dehydration, unable to ingest food. In Sue's case, the placement and extent of the jaw lesions strongly suggest the infection reached an advanced stage. The bone damage indicates prolonged tissue necrosis rather than an acute injury. This would have caused severe pain, impaired jaw function, and increasing difficulty feeding. For a predator that relied on massive bite force and frequent feeding, even a partial loss of swallowing ability would have been catastrophic. As the disease advanced, Sue likely struggled to consume prey. Feeding attempts may have failed. Weight loss would have followed. Eventually, starvation or dehydration would have ended the animal's life. This was not a violent death. There is no evidence of trauma, no evidence of predation, no catastrophic event. Sue likely died quietly, weakened by a microscopic parasite. Even more significant is the broader implication. Similar jaw lesions have been identified in multiple Tyrannosaur specimens, suggesting this was not an isolated case. The presence of the same pathology across individuals implies the disease may have been endemic within Tyrannosaur populations. If transmitted through biting, scavenging, or social interactions, trichomoniasis could have spread efficiently among apex predators. This challenges the assumption that top carnivores were largely immune to population-level health pressures. It shows that disease, not competition, not injury, could regulate predator survival. Sue's death demonstrates a crucial reality of prehistoric ecosystems. Apex predators were not invulnerable. They were biological organisms subject to infection, immune failure, and physiological collapse. In this case, the most powerful terrestrial predator in Earth's history was undone by a pathogen still affecting birds today. No rival, no hunt, no asteroid, just disease and silence. Finally, 66 million years ago, at the very end of the Cretaceous period, a small Thescelosaurus experienced the final moments of the age of dinosaurs. The evidence comes from the Tanis fossil site in what is now North Dakota, a locality preserved within the Hell Creek Formation. Tanis records a catastrophic event layer unlike anything else in the fossil record. Sedimentology shows a massive, high-energy river deposit laid down in a matter of minutes. This was not a flood caused by rainfall. It was a siege wave, a powerful standing wave generated when seismic energy from the Chicxulub asteroid impact traveled through the Earth's crust and displaced inland waterways. Seismic modeling indicates that these waves reached North America within tens of minutes of the impact. At Tanis, fish fossils are preserved in chaotic orientations, their bodies aligned with flow direction and rapidly buried. Critically, many of these fish contain glass spherules embedded in their gill tissues. These spherules are impact ejecta, molten rock blasted into the atmosphere by the Chicxulub collision and then raining back down. Their presence inside the gills proves the fish were alive when the ejecta fell. This establishes an exact time frame. These organisms died during the initial fallout, not days or years later. Among the fish lies one of the most extraordinary fossils ever recovered, a severed leg of Thescelosaurus, preserved with skin impressions still intact. The limb shows no signs of scavenging, no weathering, no transport abrasion. It was torn from the body violently and buried almost immediately. The most likely explanation is direct physical trauma. The Seiche wave would have carried trees, boulders, and debris at high speed. A collision with floating material could easily have severed the limb. Once incapacitated, the animal would have been swept into the churning river system. Within minutes, it was entombed under sediment, fish, plant matter, and impact debris. This dinosaur did not die from starvation. It did not die from climate collapse. It did not die from ecosystem failure. It died during the opening moments of the mass extinction itself. Stratigraphic placement shows the fossil lies directly beneath the iridium-rich boundary layer associated with the asteroid impact. This places its death within the first hour of the event, possibly within minutes. The Tanis Thescelosaurus represents one of the earliest confirmed victims of the extinction. It provides direct physical evidence that some dinosaurs died almost instantly, as the consequences of the impact propagated across the planet. These fossils are not myths, they are data. They record lives, not legends. Dinosaurs were not just apex predators and giants. They were animals that endured injury, disease, hunger, parental sacrifice, and environmental collapse. Extinction was not a single instant in the sky. It was millions of individual deaths, unfolding across time, and in rare moments, geology preserved the exact circumstances, bone by bone, layer by layer, proof that the Earth does not forget, even after 66 million years.